Chapter 7. The Role of Data in AI. Data is the lifeblood of artificial intelligence, fueling its ability to learn, adapt, and make predictions. Every AI system relies on data, whether structured or unstructured, to uncover patterns, make decisions, and generate insights. Without data, AI would be like an artist without paint, unable to create anything meaningful. Let's dive into one of the most fascinating areas of AI: unsupervised learning. Unsupervised learning, a step-by-step process. Imagine a scenario where you're handed a jigsaw puzzle without a picture on the box. You're tasked with grouping similar pieces and finding connections purely based on their colors and shapes. That's essentially how unsupervised learning works, identifying hidden patterns in data without any predefined labels or categories. Unsupervised learning is used in a variety of applications, from creating personalized shopping recommendations to detecting anomalies in cybersecurity systems. It's a cornerstone of AI innovation, and here's how it unfolds step by step. Step 1. Collecting and preparing the data. The journey begins with collecting and refining raw data. Unlike supervised learning, unsupervised learning doesn't rely on labeled data. Instead, it focuses on ensuring the dataset is accurate, free from errors or inconsistencies; consistent, uniform in format and structure; relevant, containing features that truly matter for analysis. Imagine this. You're tasked with grouping fruits based on their characteristics. Your dataset might include details like sweetness levels, crunchiness, and sugar content. These features form the foundation for the algorithm to discover patterns such as clustering fruits by texture or taste. Step 2. Selecting a suitable algorithm. With the data ready, the next step is choosing the right algorithm to uncover its secrets. Unsupervised learning algorithms generally fall into two categories: clustering and dimensionality reduction. Clustering algorithms group data points based on similarities. For instance, k-means works by identifying central points or centroids that best represent each cluster. Hierarchical clustering builds tree-like structures, showing how data points group together based on shared traits. DBSCAN focuses on finding dense regions in the data while separating sparse areas. Imagine a music streaming service using k-means to cluster songs with similar tempos and genres. These clusters then become the basis for personalized playlists tailored to individual tastes. Dimensionality reduction algorithms simplify high-dimensional data by reducing the number of features while retaining essential patterns. Principal component analysis, PCA, condenses variables into simpler forms. Techniques like TSNE and UMAPI preserve intricate relationships within the data, making it easier to visualize and analyze. For example, in facial recognition, PCA reduces millions of pixels in an image to just a few defining features, such as the shape of the nose or the position of the eyes, enabling efficient processing. Step 3. Training the algorithm. Now comes the magical part: training the algorithm. At this stage, the algorithm works independently to find patterns and relationships within the data. Here's how it works. The algorithm examines each data point, analyzing its features. It identifies relationships, grouping similar points into clusters, or simplifying complex datasets. Picture this. An e-commerce site uses unsupervised learning to group customers based on shopping habits. The algorithm might identify clusters like frequent shoppers, seasonal buyers, or one-time visitors, providing valuable insights without relying on predefined categories. Training an unsupervised model is like organizing a wardrobe without knowing what's inside. It's all about recognizing patterns that naturally make sense. Step 4. Interpreting the model. After training, it's time to interpret the results. This step transforms raw patterns into actionable insights. Imagine this. A retail company uses unsupervised learning to group customers by preferences. Visualization tools reveal distinct clusters, enabling marketers to create tailored campaigns for each group, from budget-conscious shoppers to luxury buyers. The real power of unsupervised learning lies in uncovering unexpected relationships and structures hidden within the data. Step 5. Optimizing the model. Even though unsupervised learning doesn't produce right or wrong answers, Optimization ensures the results are meaningful and actionable. Here are some techniques for optimization. Cluster evaluation, assessing how distinct and well-formed the clusters are. Parameter tuning, adjusting variables such as the number of clusters to refine groupings. Feature refinement, revisiting the dataset to ensure it includes the most relevant features. For example, in customer segmentation, optimization might involve splitting overly broad clusters into smaller, more actionable groups, or merging overly narrow ones for better clarity. Optimization is like sculpting, refining the model until the insights are clear, valuable, and ready for use. Applications of unsupervised learning. Unsupervised learning offers a world of possibilities, transforming how we uncover hidden patterns and insights in data. Let's explore some of the most impactful applications. Shopping recommendations. Imagine walking into a store where every product seems picked just for you. That's the magic of unsupervised learning at work. Retailers use it to analyze customer behavior, grouping similar preferences and tailoring product suggestions to individual tastes. It's why that perfect item seems to appear just when you need it. Customer segmentation. Not all customers are the same, and businesses know this well. Unsupervised learning helps group users into meaningful categories: frequent buyers, bargain hunters, or loyal brand advocates. These insights enable companies to design targeted marketing campaigns that truly resonate with each segment. Anomaly detection. Picture a cybersecurity system scanning through billions of activities, searching for a needle in a haystack. Unsupervised learning excels here, spotting unusual patterns that could signal potential threats. Whether it's fraud detection in banking or identifying vulnerabilities in networks, this application is vital for keeping systems secure. Data organization. Large datasets can feel overwhelming, but unsupervised learning turns chaos into clarity. By identifying natural groupings, it simplifies massive datasets, making them easier to analyze and use. Whether it's organizing documents, images, or customer feedback, this capability streamlines decision-making processes. By following the five-step process, collecting and preparing data, selecting an algorithm, training the model, interpreting results, and optimizing insights, unsupervised learning becomes a powerful tool for uncovering the unknown. It's not about finding definitive answers, but about discovering new perspectives that guide better decisions and fuel innovation. In the ever-evolving world of AI, unsupervised learning is the key to unlocking potential hidden within data. Accuracy, completeness, and consistency. Data is the bedrock of every AI project, but its true value lies in its quality. Poor quality data can cause a cascade of problems: inaccurate predictions, flawed decision-making, and diminished system performance. At its worst, it may even lead to legal and ethical violations, eroding trust and credibility. Ensuring high-quality data is essential for maximizing the effectiveness of AI systems and avoiding costly or harmful outcomes. Data accuracy. Let's talk about accuracy. Imagine you're building a healthcare AI system, and the training data has a serious flaw. Benign skin lesions are mislabeled as malignant. What happens next? The algorithm could misclassify healthy patients as having cancer, leading to unnecessary treatments, stress, and a massive erosion of trust. But why does inaccuracy happen? Maybe it's errors during data collection. Or maybe the information is outdated, irrelevant, or affected by human bias during labeling. And the consequences? Misleading predictions, poor decision-making in critical areas like healthcare or finance, and increased costs, not just financial but reputational too. To combat this, organizations need thorough validation processes, regular updates, and careful oversight during data collection. In short, accuracy is the cornerstone of reliable AI. Data completeness. Now let's picture a different scenario. You're working on an AI model designed to predict disease risks, but your dataset is missing key information, like dietary habits or genetic data. Without these crucial pieces, the model's predictions will fall short, potentially leading to inappropriate or insufficient treatment plans. Why does this happen? It could be gaps in the data collection process, missing details from manual entry, or a lack of integration between data sources. The impact? Reduced reliability and effectiveness of the model, which means faulty predictions and poor decisions in critical areas like healthcare. How do you fix it? By establishing rigorous data collection protocols and performing regular audits to identify and address gaps. Completeness is what ensures your model has all the ingredients it needs for success. Data consistency. Consistency is all about ensuring that data remains uniform across all sources and formats. Imagine this. One database records cholesterol levels in milligrams per deciliter, while another uses millimoles per liter. Without converting these measurements, your AI could produce wildly inaccurate predictions for something as critical as heart disease risk. Inconsistencies can arise from variations in data entry standards, synchronization issues between databases, or multiple formats being used without proper integration. The result? Misaligned datasets, increased errors in decision-making, and compromised reliability of your AI system. The solution? Standardize your formats and adopt robust integration practices. Consistency ensures that your data speaks the same language, no matter where it comes from. Data validity. Validity is all about ensuring that data adheres to logical rules and measurements. Imagine your dataset includes a patient's age recorded as 200 years, clearly an error, whether due to a glitch or manual entry mistake. Invalid data like this could completely derail your AI's predictions. So how does invalid data creep in? Human errors, system glitches, or a lack of validation rules during data entry. And the consequences? Unreliable predictions, incorrect resource allocations, and a loss of trust in your AI system. Here's a key distinction to remember. Accuracy is about whether the data correctly represents reality, like recording a patient's age as 30 instead of 40. Validity, on the other hand, is about whether the data makes sense within logical constraints, like recording an age of 300. To ensure validity, organizations should set clear rules and use automated checks to catch errors before they cause problems. Data integrity. Finally, let's talk about data integrity, maintaining accuracy, consistency, and reliability throughout the entire data lifecycle. Picture this. An AI system predicting patient health risks depends on medical records that must remain accurate as they're updated or transferred between systems. If those records are corrupted by faulty equipment, human error, or even a cyber attack, the AI's predictions could be disastrously wrong. Compromised data integrity can lead to reduced model effectiveness, inaccurate predictions, and increased risks in critical areas like healthcare and finance. To prevent this, organizations need robust cybersecurity measures, automated tools to detect corruption, and regular audits to ensure accuracy and consistency. The pillars of data quality. High-quality data is the foundation of every successful AI project. By addressing the 5 critical dimensions of data quality, accuracy, completeness, consistency, validity, and integrity, organizations can minimize errors, enhance trust, and optimize AI performance. Each dimension plays a unique role. Accuracy ensures the data is correct and reliable. Completeness provides all the necessary information for effective analysis. Consistency ensures data aligns across different sources. Validity confirms that the data adheres to logical rules and constraints. Integrity safeguards the data's trustworthiness throughout its lifecycle. By focusing on these pillars, you're building AI models capable of making accurate predictions and sound decisions. With high-quality data as your foundation, you're not just creating an AI system. You're setting the stage for meaningful, reliable results.